Hey, this is Mr. Reed, and this is the AP Physics C Mechanics Exam Free Response question number 3. This is from the May 14th, 2025 exam. This is the brand new exam format, and so I'm going to walk through each question. This is question number 3, which is an experimental design and analysis question, what we call a lab question. It's only worth 10 points, but this is one of the longer problems. It's suggested time of 25 to 30 minutes because they want to give you enough time to develop that procedure. You're going to create specific scientific procedures with this question number 3 that can be used to, with appropriate data analysis techniques to determine an answer to a question. And you're going to always have to do 3 things. Number 1, you're going to have to come up with your own experimental procedure. Number 2, you're going to have to take that experimental procedure and describe how you would create a linear graph. Then they're going to give you data, and they're going to have you determine what values you need to graph. They're going to actually have you graph that data. Then using that graph, and probably the slope or the y-intercept, be able to calculate an experimental value. So let's get to this question. This question is about, we have you can see it's a potential energy to kinetic energy type problem. We have a pivot up here. We have a rod with negligible mass, and we have a block right here. And this block is going to be at this gravitational potential energy at rest up here. It swings down at this lowest gravitational potential energy, which means we have all kinetic energy right here. The block's going to be flying out of here, and you can see it says the block is launched horizontally, and it moves along a surface towards a motion sensor that measures the speed. So it comes out with a velocity. It's got a motion detector right here that's going to measure the speed of that block right there. And so it's going to ask us to experimentally determine the acceleration of gravity using a linear graph. So how I like to do these types of problems is I like to go to, before I start to do my experimental procedure, I like to go to the mathematics first. So I have a gravitational potential energy equals kinetic energy, conservation of energy. mgh, that height that we dropped it from, is going to be equal to 1/2 mv squared right there. 1/2 mv squared. And so as we take a look, the masses cancel out, which means I have v squared is equal to, I'm going to multiply this 2 on this side, 2gh. I have my independent variable right here of height. I have my dependent variable right here of velocity squared. So first thing to do is we want to measure the height of the block with something, with a meter stick. You could also use maybe a digital technology for that to measure the height. You could use a camera with where the height is, and so you could know the height with the meter stick, but you got to measure it with something. And next thing, as you drop the block system, you're gonna drop this box block system, and as you drop it from rest, we want to make sure we're going from rest, and as the block comes out, we're going to measure the speed, we're going to measure the velocity using the motion detector. Sorry about my writing here. Using the motion detector, or the motion sensor right there. And then what are you going to do? You're going to repeat the experiment with different heights. And you're going to measure the heights and the output of the velocity, of the speed right there. So you're going to do that with different heights. You're going to measure the resulting speed. And then you're going to repeat this same procedure 5 to 8 times. We want to make sure we say that we're going to do this multiple times to reduce experimental uncertainty. Okay, we want to make sure we get all of our points. And that is what we're going to do right there. That's our procedure in order to measure this constant of gravity. Now, what are we going to graph is what they're going to ask next. And you can see we have our v squared equals 2gh, which means what are we going to graph on the horizontal? We're going to graph this height. What are we going to graph on the vertical? We're going to graph v squared. And what is our slope going to be equal to is 2 times gravity, which means gravity is going to be equal to the slope divided by 2, 1/2 of the slope. And that is describing how we would do that data right there. Now you can see they changed up this experiment in part C to add some friction right here. And this friction has a coefficient of friction of mu, and it's going to go to x is equal to x naught. It's going to come back to rest right there. And so what they're going to ask us is, how are we going to graph this? They did a similar experiment with, they did the maximum heights, the input, the independent variable, but they didn't measure the velocity. They measured the x max that it would come to rest. So again, I always like to go to the equations to figure out what's going on. We have our mass times gravity times height, and this comes through, becomes maximum kinetic energy when it's at the lowest point, but then it goes into the work of friction. This is the work energy theorem right here. And so mgh is equal to the force of friction times the distance that it goes, which is my x max right here. What is the force of friction? Is the coefficient of friction times the normal force, which is mass times gravity, times x max. What cancels out here is the masses right here. What also cancels out here is gravity. And so what do we have here? What do we need to graph? We have height we can graph on our y-axis because y equals mx. Our m is going to be this coefficient right here because that's what we're going to determine at this point. What's our independent variable is going to be this x max, what we're going to graph on our x-axis. And you might say, well, our independent variable is actually the height and our dependent variable is actually the x max. Well, you can move around the equation if you want to, and you can graph it differently. You can just graph it this way, though. You can graph it either way. What are we going to graph on our vertical axis is height. What we're going to graph on our horizontal axis is x max. Again, if you wanted to switch this around and have 1 over mu times height is equal to x max, you could graph it that way. It's just your slope would be 1 over mu. Since I'm going to graph it this way, my slope is just going to be mu, which is going to be really nice and easy there. So I'm going to graph this. And students, knowing how to do a graph is very, very important. My class, we do this all year. We do it from the first week to the last week. So we have x max, and the units of x max is meters. Our vertical axis is going to be the height, which is in meters as well. You can see the meters are going to cancel out. That's why mu doesn't have any units. And you can see we want to go all the way to 0.9, sorry, the x max. We want to go all the way to 2.3. And so we want to split this up equally. We want to use as much graph as possible. So I'm going to use 1, 2, 3, 4, 5 is going to be 0.5. 1, 2, 3, 4, 5 is going to be 1. 1, 2, 3, 4, 5 is going to be 1.5. 1, 2, 3, 4, 5 is 2. 1, 2, 3, 4, 5 is 2.5. I'm using more than half of my graph right there. You can see on this axis, I want to go to 0.9. So I could use, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, okay? I can use a little bit, I could spread it out a little bit if I wanted to, I don't have to, and then I'm going to graph my points on here. I'm going to graph my points. So we have 0.3 on my height, we have 0.76, which is going to be about right here, 0.76, sure. 0.45 is going to be right here, 0.45, and 1.1. We have 0.6, you're getting the gist of it, 0.6 and 1.4. You can see this is definitely linear. 0.75 and 1.9. 0.75 and 1.9. I think I'm doing okay. And 0.9 and 2.3. 2.3 and 0.9. Okay. And I'm going to do a best line fit, whatever my best line fit is. I'm going to use a ruler there. And I'm going to pick 2 points. 2 points. And how I'm going to pick my points is, you can see I'm going to pick a point like this where I can get a good slope here. I'm going to get a good slope right here or something like that, where I can kind of zoom in and call that a number that I can estimate a number. I like to have it on the vertical axis or the horizontal axis. You can see my vertical axis is right on this line. It's right on this line. My this axis right here, I can kind of guesstimate what this number is. I'm going to do the slope, the rise over run, and my rise over run. My slope I got when I did it on my calculator, I got 0.38, which is a great slope for mu. Now again, if you graph that differently, if you graphed it the height and x max, your slope would be 1 over mu, which means you would have to do the reciprocal to get this mu of 0.38. And that was question number 3, the AB Physics C Mechanics free response question. Hope that helped, and I'll see you around.